Welcome to Study Loop.
Okay, in this question we have to satisfy the boundary conditions. So we have given the function minus infinity to infinity f of x partial the del x dx. So the first condition is when c is greater than 0. So we have given y is equal to cx. So dy by dx is equal to a c. So 1 out of c dy is equal to dx. So we put in above function which is minus infinity to infinity f into y by c uh, del y 1 out of c dy. So therefore 1 out of c minus infinity to infinity f y by c into del y dy. So we have a formula. We know that this is y out of f of y. This is not c f of y. So we know that we also know that we have a formula which minus infinity to infinity f of x partial derivative x minus a dx, which is equal to f of a. So here a is equal to 0. So therefore we can write it as 1 out of c minus infinity to infinity f into y derivative of partial del y into dy is equal to 1 out of c f naught. And for the second condition, which is c is less than 0, where we do the same calculation as the function is minus infinity to infinity f into y out of c del y into dy by c. So therefore we can write it as minus 1 out of c minus infinity to infinity f of y out of c del y dy. So therefore this is equal to minus 1 out of c f naught. As c is negative, so we so minus and minus sign become plus, and we can write it as 1 out of c mod f naught. And in the second part of the question, we have to prove that the function theta x equal to 1 when x is greater than 0 and equal to 0 when x is less than 0. So we have to prove the derivative of this function with respect to x is equal to del x. So we know that the function minus infinity to infinity f of x d theta out of dx is equal to minus infinity to infinity f of x del x to dx, and this should be equal to f uh, to 0. So this function is minus infinity to infinity f of x d theta out of dx. Dx is equal to f of x theta x, that is from minus infinity to infinity, minus infinity to infinity theta x f of x dx. So therefore we can write it as f into, by putting the limit which is to infinity, minus infinity to infinity theta x f dash x dx, minus infinity to infinity theta x f dash x dx. So this whole term is equal to 0, as the limits are from 0, x is greater than equal to 0, and this term is equal to 1. So we have only term which is f infinity minus infinity to infinity, minus infinity to infinity f dash x dx, and this can be written as f of infinity minus f of x infinity to 0. So therefore we can write f of infinity minus f of infinity plus f of 0, and these two will get cancelled. So we have only left f of 0. So this verify that partial derivative of theta with respect to x is equal to del x.